All right, so today we are doing a workshop on site reliability engineering. And site reliability engineering is something that I'm pretty sure I checked the ASU coursework, and that is not taught anywhere at ASU. And most universities do not teach anything to do with SRE, site reliability engineering. So we're going to do a hands-on workshop to teach you more about some general concepts. And this, again, is for software engineers, product managers, project managers, anyone who is going to work with software. I am Greg. Right now, I'm an engineering manager in Reality Labs at Meta. I've been there for about 11 months. And then before that, I was in an ads team at Meta. And before that, I was at PayPal for 10 years. In my free time, I love to eat gelato. And I've been like a hardcore gamer, I guess, since high school. That's me in the lower right corner on my first computer playing some StarCraft. What's up, Han?
Your favorite gelato flavor and what's your favorite game?
Favorite gelato has got to be hazelnut. Favorite game, it's probably got to be Portal, just because it's like, interesting from the mind, and then it's like action oriented. Portal, love it. Who has written code? This is just me for me to get a sense of who wrote code, who has written code in their lives. In their lives. Cool. Hands, hands, hands. This is good. All right. Who has deployed that code to like AWS, Google Cloud, anything like that? Okay. Okay. Amazing. Amazing. So this talk is basically like what happens after you deploy the code, because everyone thinks about writing code as like the main thing. But once you deploy it and people are using it, you need to know how it's being used and how well it's being used. So that's the talk. That's the point of this talk. So we will build it's a real web application, but it's really basic web app. I'll show you the professional monitoring tools that all the big companies use. These are like free and open source. And then we'll look at the mission control dashboard, and then we'll talk through some skills that site reliability engineers use. Okay, so everyone ideally should know the metrics as it relates to your software. If you're a PM, does anyone want to be a PM, product manager? Anyone want to be a project manager? Okay, cool. Does anyone want to be like a designer, UX designer, anything like that? A little bit, okay. What about like a DS, data science or data engineer? Okay, cool. All of these at some point you'll be monitoring something to monitor the health. So you should get alerts, ideally. If someone breaks production, you should get alerts. Even if you're a PM, even if you're a designer, you should know that your product is healthy or not healthy. Ideally, you don't break production if you're a software engineer, but if you do, you normally have this blameless postmortem process that's part of the SRE, the site reliability engineering culture, that I think was created at Google. The first SRE book is a Google SRE book that I know of. And then finally, you'll set up all of these alerts. You'll know how the health of your system is. And I really hope those alerts are not noisy, because that's like the main thing when anyone's on call, and any big company or on call, you carry a pager, quote unquote, and you're fixing code. The worst thing is to have a bunch of alerts that don't work correctly. So we'll talk about alerts and how we might tune those alerts. I have this like why this matters slide, because if you're watching like Netflix and for some reason it doesn't work, or you're like using Amazon and for some reason it doesn't work, you have to know that like someone knows that you're getting a 404, a 500 error, you're getting some error. Someone has to know that at those companies. If you're running your own code and you push your own code to the cloud, you probably didn't think about how you're going to monitor it. And that's kind of what this talk is today. So you could take what we've built and then you could wrap that around your own code, and now you can monitor your own code. So like gaming companies use these concepts to monitor things. Instagram definitely uses this to monitor their code. And so we'll use the same tools that they use. This is sort of an easy one. Can anyone give me an example of a vital sign? A vital sign. Any vital sign? Vital sign. Han.
to code 200.
No, I'm talking human vital sign.
Beating,
Heart rate, heartbeats, yes. Do you want a sticker? Do you want some glasses? Or do you want a meta pin?
I'll hold on to you the better.
Meta pin. All right. Put this right here for you. Cool. Yeah, like a heart rate vital sign. Very simple thing. So what we're talking about is the vital signs of code, of software today. We've got people using your website. That website has some sort of backend thing and then has a database. All of that should have monitoring and alerting, ideally. Those are the vital signs of your software. And again, like none of this is taught in school, unfortunately. I really this is an SRE101, if you will, type introductory for everybody. All right, so if you're just joining and you want hands-on experience, we're gonna be doing all of this live with GitHub. So SRE.ohack.dev brings you to GitHub that looks like this. And then you click on code. Hopefully it doesn't say local. This Codespaces one is the one you want. And then you click the plus sign. So that's what we're gonna do now. First thing we're going to do is actually set up the environment. Has anyone actually heard of, used Docker before? Sweet. Why do we use Docker? Go ahead. Containers.
To run code on isolated environments.
Love it. You got sunglasses. Oh, you also have, I have an Instagram sticker. Sunglasses, Instagram sticker, Facebook sticker. What do you feel?
Sunglasses.
Sunglasses.
Thank you.
And then what was do you have another thought?
I was going to say so that different teams can use the code that you produce, so it's like universal.
Yeah, so anyone could take your Docker container and use it the same way. Hopefully less stress, easy to set up.
Download like everything that you've downloaded.
Right. Yeah, they don't have to go step by step and read your documentation of how to download a bunch of stuff. They just get it. It just works. Yeah. Let's see. Do I have any more? Oh, I have a WhatsApp sticker, I guess, too. WhatsApp sticker? Cool. All right, so while I'm doing this, ideally everybody does. So Docker compose up -- build. I'll do this live. So we go here, we go to Codespaces, we hit the plus. Might take a little bit to get this going. It sets up a code space. And then this whole thing should drop down. That looks good. And then eventually I get a terminal. Yes. And then, yeah, I have command line. So now I can actually type something. So we're good to go. So I will copy this and I'll put it in here. And I will have to allow me to paste it. And so you should get something that looks like this. So down here where my cursor's at, you see that it's doing a bunch of things. It's grabbing all of these packages. And I think the next slide talks about it. No. We'll actually go down to this. So we have our app. That's a real web store. We have Grafana, which is like the dashboard in your car. We have Prometheus, which is recording all of the metrics. And we have Tempo, which lets us actually trace calls into the software, and we can see the full, how the software is being used from front end to back end. So those are all the things that are installing as we do this build command. Let's go back and let's check on it. So we're still doing some things. We're getting some Grafana and Prometheus. Memcache is just a caching thing that's been pulled. So we're waiting for those two things. Is this already working? Does everyone have this running? If you're following along, cool. Okay. So the first thing we'll do is we're going to click on this globe icon for the port 5173. So if you go to ports, which mine's not ready yet. If you go to ports, and in there, you should see 5173. You're going to click 5173 is right there. There's a little globe icon. It says open in browser. If you click that, what happens? Yes.
Error failed to catch product.
Yes, we get an error. Amazing. Do you want Do you want another sticker?
The Instagram one.
Cool. Thank you for clicking on the globe and thank you for getting the error. Okay. Am I up and running yet? Let's see. Almost. Almost. We're getting an error. Hopefully this checks. Yeah. So we have a bunch of firewalls here. This is like a little aside, but kind of important to describe. So 5173 is this front-end React, and then it calls out to these two other services that we have not opened up for public use. So you get this error when you click it because we haven't opened it up for public use. We're almost there. We are provisioning the back end. We're exporting some layers. So what we're going to do is we're going to make 2 ports public. So we're going to make 8,000 public, and we're going to make 9091 public. Let's do that now. So the way that you do that is you click on 8,000. It should pop open this thing where it says port visibility. You will select public for those 2 ports, 8,000 and 9091. And that should be everything we need to get it going. So 8,000 is important because 8,000 calls our backend, which has all of our store information about the things that we want to put on our website. And 9091 doesn't really matter a ton, but that keeps track of the fact that people are clicking on our website and doing things like that. Yes.
I'm not saying port 8,000.
Great. Amazing.
Oh, okay. Was that?
So you're not seeing, no, that's another bug.
Oh,
So port 8,000 is this backend service. If that's not running, that's not good because that means we're not being able to like serve out our information for the backend. So I actually got, as you were saying that, hopefully you can read that. It says on the backend one node, it says not found. So yesterday when I did this, something had changed since the last time I had set this up. I went into Claude and I said, I'm getting this weird error. Why is that? And the fix, without having to like go through it too much, is in my Docker file. Oh, backend Docker file is. Oh, it's this right here. So this version 3 apparently doesn't need to be used anymore. That version 3. So look, actually, let's go in. So let's use the power of AI and show you how I did this. So I actually said, hey, I'm getting this error, right? The error that everyone saw. This is my requirements.txt. This is my Docker file. This is my Docker compose file. Gave it everything that it needs to know. And it said a bunch of things, but it was like, this error is probably because this most likely error was because of this problem, which is not true. So that one was not correct. This one was also not correct. And then this one was also not correct. So then I had to say none of these worked. And then I said, I'm worried it's a version issue since it worked 10 months ago when I got this set up. And then it literally said, remove that line. So then giving it that context, now it says, okay, do this instead. And now this should work. So you do Docker compose down, and then you do Docker compose build -- no cache, and then you do Docker compose up. Okay, looking good. Yeah. Okay, so I'll just go ahead with this, and then I'm pretty sure that was the fix, but maybe I'm just doing it out of order. All of this is rocking now. Yeah, there's the back end that's up and running. So that's what it should look like. I'm pretty sure those are the only fixes. Okay, so I'm gonna make those ports public. So I'm gonna go to ports, 8,000, port visibility public, 9091, port visibility public. And then I'm gonna go back to the 5173. And 5173 should give me this hopefully beautiful page, expert UX designed. that looks like this. This is my store. Man, that's so beautiful. So we have laptop, we got smartphone, we got headphones, and we have doesn't exist, which is great. Let me go to inspect, and I will reload this page so that everyone can see this. So this is actually trying to load all of our products. We have product 1, 2, 3, and 1, 2, 3 again. It calls this /collect, and then it has a product that says doesn't exist. I'm actually getting an error there. That's a 422 error. So now, if I want to, I could try to buy a smartphone by hitting purchase, and that number, every time I click it, should go down. Yep, it's going down. That's great. So every time I'm doing this, I am performing a purchase. I'm calling the backend's performing a purchase. This doesn't really work. I'm not spending money, just to show you all how this works. So now that we're doing that, we're going to run a load test really quick. So I'm going to come in here. I'm going to copy these two commands. In here on terminal, you can actually hit this plus button and you can open another terminal. And I'm going to do pip install -r requirements -r or pip install -r requirements.txt. And then I'm going to run this load test. And hopefully if this works, yeah, I start to get a progress bar at the bottom. It says running load test. So now I am actually bombarding this website with a bunch of traffic. And that should go on for a few minutes. Yeah, this one. Pip install, which do you want to see run load? You want to see it? You want me to open it? Yeah. Should be right there. So it runs this Python, it runs load test.py with the URL. And this load test looks like this. So it's running through a loop of all of these products. I know that this product doesn't exist, so that'll give me a 404. It's looking through status codes. It's counting up the errors. And then it prints out the results when it's done. It's pretty basic. You could use this on any website to just generate traffic. Do you want a Instagram sticker? Do you want a Facebook sticker? Which one? Instagram sticker. Cool. All right. So now we're going to go and look at monitoring. This is like the actual goal of this talk is to go look at monitoring, which was on port 3000. So I'm going to go back to my Codespaces. I'm going to find 3000 at the top. I'm going to click the little globe icon, and it should load into this beautiful Grafana dashboard. But when you go there, it's like nothing happens. So you don't really see anything. What you really want is this dashboards tab. And then there's a dashboard called application metrics that we created as part of our Docker container. And then everything's in the way. Let me go back here where it says last 6 hours. I don't want that. I'm going to go and say last 5 minutes. So this shows our load test is working. We're getting some errors. Success rate, we have some response time is 2 seconds. So we already see our beautiful dashboard. It works as we expect. To get into there, you might need to do this admin is the username and password to get into Grafana. So after you click on the 3000, it'll ask for that. Then you click on this little skip. By the way, the slides, all the stuff that I'm going over is in SRE101hack.dev. Should have a giant link right there. These are the live slides that I'm using right now. So you do admin, and then it asks you to reset your password. Just hit skip because we don't really care. This is our own little environment. And now let's talk about Red, which is probably the best album, but also, more importantly, rate, error, and duration. So rate, error, and duration is like SRE101 type things. Does anyone know what rate means? Rate, in terms of rate, error, and duration. What do you think rate means? Response rate, how often the errors happen, close. E is actually how often the errors happen. Response rate. It's actually the request rate. So the number of requests I'm getting is the R, and then the E is the errors that I'm getting. Hopefully it's 0. And then duration, does anyone know what we measure duration? What unit of measurement we use to measure duration? Seconds? Milliseconds? All that's good. Usually milliseconds. So this is what the dashboard looks like for rate, for error. And then I want to talk really quick about the Doherty threshold. So if you click on this, this looks so much better than my slide. But basically, 400 seconds, under 400 seconds is like this Goldilocks zone. If your app, if your website responds under 400 ms, 400 milliseconds, then basically no one has to wait. Like the person using your website doesn't perceive any latency. If the app can continue to respond really quickly, that gives them the best feeling of a UX that they could possibly have. This is sort of really challenging to do under 400 milliseconds, but that's the goal. That's like your ultimate goal, is to get really low latency. That's what this duration is. So let's talk a little bit about rate. Let's go back to my dashboard here. So this is requests per second. Can I make this larger? So we got requests per second. That's R in red. We see 3 lines. We see products. We see the root / is just the main website. And then we see this one, which is purchases. So if you were running a commerce website, you would really care about the purchase one, because those are people actually hitting your website and actually converting and buying something, versus people just hitting your website and versus people just viewing your products. So this one is amazing. Then we go to error rate. So this is the percentage of requests for which you get an error. Ideally, you want this to be 0. I wrote bad code on purpose to generate an error rate, to generate problems. So you see that continuing to increase. The way the code is written, it basically picks a random number. If that random number is a certain number, then it, or above a certain number, then it makes an error on purpose. Then we have a success rate, which is the opposite of error rate. And then we have total errors. And then we have response time, 2.43 seconds, which is pretty terrible. If you can't hit 400 milliseconds, you definitely want to get under 7 seconds. And then there's this happy median area in the middle, which is 3 seconds. If we're talking about payments, usually you want under 3 seconds for payments. So there's all these like target latency numbers, depending on what the person's doing. Do you have a question? Yeah.
Are these based on APIs? Like each API is supposed to work based on purchase, one is on viewing the product. So each of them have different thresholds.
So thresholds is a different topic. Thresholds is like, hey, I need to have an alert if I see anything above this. We'll get into that.
Oh, I just meant the response time. Suppose it's
These are like industry best practices, I guess. So under 400 milliseconds, Goldilocks zone, you'll probably never get there, but you're always aspiring to get under 400 milliseconds. 3 seconds is like right where you're starting to perceive latency and you're starting to like, this app is slow. And then 7 seconds, if you go above that, people are like breaking their phones. They're like, I don't want to use this thing anymore because I'm not waiting more than 7 seconds. So we're at 2.4. So like as I go and click on the app and I click on this and it goes from 10 hopefully to 9, it's actually not responding. Let's refresh. So I actually hard-coded a latency into the refresh as well. That's why it takes a long time for this page to load. You'll see right here, should have, the time, which is on the far right column. It'll say how long it's taken each endpoint to respond. And the ones that are like products, 13 seconds, 15 seconds, those are super long. This metric here is giving us the average response time. Yeah. You have no data because you need to generate data. You can go to, if you go to our here and you open up 5173, pretty sure it was, this should take you to the website. Our front end website takes a little while to load, the one that I just showed. And then once you get to the website, it'll start generating metrics. And then you have to click a button, and that button, like if I click purchase, that generates the purchase metric.
When I go to the website, it's that failed to fetch products.
Yeah, that's because the backend isn't running for you. So I'll finish this, and then we'll try to get the backend running for everybody. But it can't fetch products if the backend's not up. Cool. Okay. Majority threshold. All right, we talked about rate, error. Let's go a little bit more into latency, because this one is the mother of all metrics. If you've got people using your website and you have low errors, but your latency is high, people still aren't going to buy the thing that you're trying to sell or use the game that you're providing. So let's go a little bit more into this one. This one, if you go back to the slide, right here, I have Explorer. You go to Explore, then you click on Tempo, and then you click on this query type search. I'll do that kind of live. So I go to Explore, and then I see this thing. I pick Tempo, and then I click Search. And when I do that, I get all of these really cool trace IDs. Timestamps tells me how long they took. So this is every single request that is hitting my system generates one of these trace IDs. If I click on the first one, let's see what we get. So now I get kind of like this swim lane diagram. It's called many different things, but it tells me that my database query took 547 milliseconds to run. I have a recommendation service that I'm using maybe to recommend things. That took almost a second to run. And so this shows me top to bottom exactly all of the calls that were made and how long they took. If I click on one that hopefully is an error, I should get, some of these should be errors. I should get something that's red. Please give me one that's red somewhere. We're all successful. Wait for it. You can filter. So this is kind of challenging with a small display. There's this add query here. So you can filter by actually adding a query here. The other way to do it though is you can go to table. Does that work? No. We can just change it up here. Status is error, and I think you hit refresh. Yeah, so see how that as red, right where my mouse is? So that was a failure. You can filter up here at the top for them. You can filter based on duration and other things. So if I click on this, it actually says it's 404 product not found. Yeah, you can see that. It gives me some other information here, but mostly not useful. It was product 999, which doesn't exist, so that makes sense. There's a pretty table view of it. But essentially, our code is randomly generating errors. And so this lets us filter for errors. We can see if there's extra latency that may have caused the error. We can see the actual error, which is one of the big things in software world is you get this error, but what's the underlying status message? So now we can see that. They're going to be pretty much all the same because I filtered for error. But you can see kind of like if I move this over, you can see the durations are all kind of within a second or so. There's the 2-second one. Yeah, so Tempo is the open source thing that you add to Grafana and your code so that you can actually see the full trace, which is an amazing thing to have. The SRE term for this is observability or O11Y. I don't know. Everything is like internationalization is O11N, right? But O11Y is the short form for saying observability, of which we're using an observability tool right now, today, called Grafana. All right. Now, I have a WhatsApp notebook. Can anyone find, though, where the alerts are at in our Grafana dashboard, if you're following along, I want to see how many alerts that we have and how and what do they do. This should be available to you even if the backend didn't install. If you can find the alerts somewhere, how many do we have? And then what do they do? I just care about how many alerts did we set up.
We have two alerts.
2?
Yeah.
4 is the right answer. Let's go. Hopefully you found it through alerting. And then you have to go to alert rules and you expand this out. You have 4 total rules. And in my case, we have 2 that are firing because we are hitting a threshold, and we have 2 that are normal. We have high error rate detected, high latency detected, our service is down, everything's going wrong. So this would be a normal on-call shift. You get a bunch of errors. So here it's been firing for 10 minutes. That's because we're running that load thing, the generates load in the background. And then my code is generating errors at random. And we hit over a 10-minute period, we now have an error rate over 10% for the last 5 minutes. So now it says firing. And in this case, this would send a Slack message. It would do a text message. It would start like telling people, hey, there's something going on here because you should not have this many errors over a 5-minute period. There's a whole series of there's like PagerDuty, there's Splunk, there's all these other tools that do exactly the same thing that we're doing here. And then you see this one is a latency spike. What was our threshold? So we said if the average latency over 5 minutes, rate greater than 1. So basically, if it's over a second, over this last 2-minute period, that's not good. We want to count that because anything over a second is probably not great for us. So we want to flag that. And it has to happen for a 2-minute period before it actually triggers the alert. So we don't really want, this is how you cause noisy alerts. If every time it was over a second it triggered alert, that would not be a good alert. This is over 2 minutes. So the average of all of that, if that's over 1, if that's the latency is over this certain value, then it's probably a good time to throw the error. So all of this is configured in our GitHub repo for this. So you can go around, you can play with the different settings, you can reconfigure this however you want. This also has like an actual rule, so you can use the UI and you can create rules. If you recreate this though, it won't save anything. So everything here is configured in our GitHub repo. All right, I think we've got a couple, yeah, so those are the tools that we used. And let's do a quick quiz. So I have three opportunity hack shirts. I have this, OHAC is our nonprofit hackathon that we did last weekend. I have a medium. I have another medium. Hang on, is that right? Yeah, I have one medium shirt. I have another medium shirt. And then I have a large. Oh, and then I have one more. Oh, that's mine, just kidding. Cool, and then I have a bunch of stickers, opportunity hack stickers. I have a bunch of things. So I'll give away whatever you want if you can answer what does red mean. Yes. Beautiful, beautiful. I'll put the shirts down here if you want to pick a shirt, and then I'll put the stickers down there if you want to grab the sticker. Cool. And then SRE, does anyone remember what SRE? You're really fast in the back. Yes, site reliability engineering. Cool. If you want to grab a shirt, sticker, those are the two important topics for today. I think I have this guy. All right, so we learned how to monitor a real application. We had a front end and we had a back end. We didn't really fix the issues. I guess we could fix, I'll show you how we could fix something really quick. In the backend, if I open up app and then I go to main, let me make this a little bit bigger. Scroll down, there we go. So here I'm actually saying, hey, every so often throw a database connection timeout error. So this, I'm just hard coding the failures. And then here I'm saying every so often, give me an external service unavailable error. And then somewhere in here, I'm doing probably a sleep. Yeah. So here I'm inducing latency by just sleeping, stuff you should never do in code. But this is how I would go and fix these problems. Once these are fixed, I would rerun it and rerun my load test. And hopefully I don't see any errors. I don't see any latency. Everything is great. All right, next steps. So you've got SRE101.dev. That'll take you to the GitHub repo and these slides. And then finally, like, there is a career path, even though you may not realize it until after this talk, in site reliability and production engineering. These people tend to love bugs and troubleshooting bugs, diving deep into them. I did this for 6 years or so. Really, it just means that you love finding errors, looking at logs, looking at observability stuff that we just did. So I hope you take away that. And then finally, this Measure What Matters book is probably a highly quoted book in the software world. If you're a product manager and you've got a product that people are using and you're not measuring success, you're probably not doing a great job. So this tool helps you monitor that product. And this book basically walks you through all of the things you need to understand or think about when you're measuring success. So it talks about OKRs, objectives and key results, which is something that most companies use as the terms. But the tool that we built today, the tool that you can use, allows you to now measure what matters. That is it. I have a few minutes if there's any questions, and then we can get the back end running, if anyone.
Production engineering, same as production.
Same thing. Yeah.
How about DevOps?
DevOps is like the old term, I guess, for SRE. Similar. DevOps focuses a little bit more on continuous integration, continuous delivery. Usually it's like, how do I take the code that I've written and get it to production in some repeatable pattern? That's usually more DevOps than it is SRE. Same idea. They're all related.
In your team or your organization, for the same person who you have different rules for it.
So at PayPal, you were an SRE. That was your role. You would go work with software engineering teams. You would like be embedded in those teams, and you would teach them all the stuff that we just did. You would teach all of the software engineers how to do monitoring and alerting and all that. That was your role. At Meta, we have production engineers who we don't really work with all the time, but I might pull in a production engineer if I'm trying to improve performance for a system. They don't sit on our team full time, and they kind of rove around depending on who needs them at the time. But it is still a role that somebody has. Like, that is your job title. You're not a software engineer, you're a PE.
Is there duty or responsibility only to figure out where those problems are and report it to the respective team, or do they solve it as well?
Yeah, so this is like over the last 10 years, what happened is you had an operations team that was in a command center. You would have software engineers deploy code, and then those operations people would be like, hey, you guys just broke everything, you need to go fix it. And then the software engineers would say like, oh, ops people, tell me where the code is at. Can you guys go fix it for us? And that creates really bad tension between software teams and operations teams. So that's why DevOps came to be DevOps, because it brings those concepts together. If you as a software engineer push bad code, you should be the one to fix it, find it and fix it. And so like, you don't really rely on a PE or an SRE now to go tell you that your code is broken. They will help you instrument your code so that you know as a software engineer, your code is broken. And that's like over the last 10 years, now it's gone to software engineers now do this as their job, as an expectation. But before it was like two separate teams. Cool. So I do have extra swag. If anyone didn't get swag, the shirts, there's one shirt left. If you want to grab anything else before I head out, feel free. That is SRE.
Thank you.
Question.
Yeah.
Are there any like particular communities or online resources that like
Ooh.
helped you make projects or develop your career overall besides any industry experience?
Online communities. I would say back then. So I was joining, there was a meetup at Melt Media Labs. I don't even know if that still exists. It's in Tempe. Meetup.com, right? So I would go there, and that's where I learned a little bit about Docker, JavaScript, things like that. There are like three meetups in Tempe area that I know of. There's definitely a JavaScript one. There's definitely I forget what we called it. It was like a cloud one, maybe a DevOps one was the one I went to. But other than that, conferences. I would go to conferences pretty early in my career to learn a little bit about a lot. There's a really good one called UberConf, which is like more about, at the time, it was about Java and monitoring, things like that. I think they rotate around, but I've been a couple times to UberCon. And then Splunk has a good one. It's called Conf. Splunk is basically this like industry grade tool that everyone uses for monitoring. And their conference, Splunk Conf, is September 11th. So it already happened in September, but that's a really good one. This is sort of like the industry. There's a couple like really popular industry tools. One's Datadog and then one's Splunk. They both have their own conferences. Yeah.
In your early career, how did you find
My company paid. I had to go to my manager. Actually, Splunk does this funny thing. Let me see if I can find it real quick. Splunk justify for manager comp. They actually give you like this how to justify the conference to your manager. And you like take that. Man, I wish I could find it quickly. But you take that and you're like, hey, manager, here's why I need to go to this conference. And then like your manager's like, all right, like you told me all the reasons. That makes sense. Yeah, my company paid for my hotel and the conference. So some of these though, they'll pay as a student, they'll like cover your costs if you apply. So you can also do that. Just depends on the conference. Yeah.
So they usually suggest us to write the metrics on our resume, like you ask, how do you measure it?
Yeah. So if you say like, hey, I saved 10% of latency on the back end for my service, if you write that in your resume, and then during the interview, they like, how did you save 100 milliseconds on the back? Yeah, that will definitely be, usually the recruiter and the manager will ask you to validate your resume. So they'll say, I see that you have that on your resume, this. Can you tell me how you did that? Yeah, definitely that happens.
So Joe recommend the way by place, but I don't know if that is real or not.
I mean, yeah, now that you have these resumes that are like action-based resumes where it has like, I saved X milliseconds or whatever, I think it's worth it to still write it, but that the how part is probably more interesting on the resume. Like you saved 100 milliseconds for every call. Did you do that because you added caching? Did you do that because there was like really bad logic in the code? Like what's the reason why you saved the latency in this case? I think that's probably more important.
Okay. So if we don't really improve that much, is that better?
Well, I think like if you improve something dramatically, whatever it is, then it's definitely critical to write. Yeah, probably 100 milliseconds of savings is not worth writing on a resume. But if you save, I don't know, 2, 3, 4, 5 seconds of latency, or you having an error rate and you've helped fix the error rate by a certain percentage, that's probably important to write on a resume.
Okay. If we don't really have that dramatic
well, for error rate specifically, so sometimes you'll have, in our case, right? What was our error rate really quick? It was, our error rate jumped up to all the way to 23%. So let's assume I could have made money off of these errors, but because these people saw an error, they didn't buy whatever I was selling. So you would go and say like the average purchase price for my product is $23. And so if I were to fix this 23%, then I could make that money back for the company. I would actually I would improve revenue. So maybe the error rate is not important to cite in your resume, but you call it like the average purchase price, do like some napkin math to say like, well, all these people that saw an error would have bought something, but they didn't. And that would be more valuable to add than the error rate, because that's a dollar amount. Yeah. Okay. I don't know how. Stop share. Cool.
In the heart of innovation, where the code meets the cause, we're building brighter futures, breaking down the walls. With every line of code, we're making dreams come true. Opportunity hack, we're counting on you.